but we're still obviously waiting for people. But just oh hey look. My oh welcome welcome welcome. Let's go. We'll start at like 5:03, 5:05 ish Eastern Standard Time. I only specified that in case somebody from my 6 hours watching, just to give people time to join, that kind of thing. But we got a decent group so far. Dun, dun, dun. Say again? 220 by 220 by 250, I think. Let me go double check that. Yep, 220, 220, 250. All right. We're about a minute or so out. Yeah, if you could bring people out of like the depths into the stream, that'd be great. Hello. Come on in, have a seat, make yourself comfortable. We'll. Yeah, once he gets back. Okay. It says there's. How are you? No worries, Jason. You can just be yourself here. All right, very good. Okay. Well, we'll get started. Hello, everyone. Thank you for coming tonight on this day. We The topic at hand today is Unity. Oh, glorious Unity. It's one of the most popular game engines in the world. It powers basically the majority of all virtual and augmented reality applications that exist. And it's also basically the driving force behind most of the largest games that exist today. So with that out of the way, we will the first thing I'll do is I'll show you these QR codes. So for any new members or people who are watching the recording, if you want to get involved with us or our partners at ICXR, these are QR codes that you would like you should scan. You can join our Discord if you haven't already and like get our announcements. You can join us on Turplink and become a quote unquote official member of the club, even though that really just means you just say you're part of us, and you are. There's nothing more to it than that. And then ICXR is for people across the country who are also interested in XR, and that's a really cool community to be with. So the agenda for today is we're going to be talking about why we use Unity, right? Because there's so many tools out there, and there's so many ways to build what we want. Why are we doing Unity in particular? We're going to be looking over the Unity basics. So I'm going to try to give you a crash course of all like the terminology you need to kind of get started, to start thinking in the Unity mindset. And then to finish off, we're going to be doing a demo where one of you guys will just pitch me an idea, a very simple idea, albeit, and we'll build it together. So it'll be a very sort of interactive thing like that. And then at the end of it, we will upload the project files so that you can look at what we built together. So first and foremost, why Unity? Why? We don't really need a game engine to make games. And that's what, if you think about it, that's what had to have happened in the past. There was no Unity when computers first came out, and yet games still existed. Of course, like some of you who happen to be more familiar with like computer programming, well, you could very well just like write a program that just takes in input from the user in the form of text, and then it will be like a sort of text-based adventure game. You can use like your browser, and you can build a game in your browser with the functionalities it provides with no game engine needed. And especially these engines can cost. Like Unity as a company, it needs to make money. It's not free from those sort of laws, so you do kind of have to pay for this stuff. It does come at some costs. So why do we do it? So I want to see if, I posed a question to you all, like why might we want to use a game engine? If you don't know the answer, that's fine. I'll tell you in the next slide anyways, but I want to see if anybody here has some ideas on why we would use a game engine like Unity.
Probably just because a lot of the tools that you would have to create from scratch are going to already be available to you.
Yep, that's a very good reason. Because you don't build a farm to make a salad. That is very true. Yep. We'll get to that. Anyone else? Yep. Well, you guys have sort of identified the major points. That being that there's a lot of things that Unity can kind of take care of you, such that you don't have to. So one of the biggest things that Unity can help with is basically all the math required to actually take your 3D stuff and put it on the screen. That is a very sort of like matrix / linear algebra intensive task, and Unity can kind of do all that for you on your behalf. Now, granted, the asterisk is there because that doesn't mean you'll never have to do math. You will in some points, but generally you will have to do less math with the help of Unity. Another big important thing is multi-platform support. So if you want to target, maybe you build this game and you want to show it to your friends. Well, some of your friends have Android, and some of your friends have an iPhone, and some of your friends have a Mac, and some have Windows, and some have Linux, et cetera, et cetera, et cetera. Normally, if you were doing it by yourself, you would have to build an application for each of these platforms. With Unity, generally speaking, they can take care of that for you. And that's pretty useful. The next one is add-ons and assets. Unity, being one of the largest engines in the world, has a huge community of creators that have already built so much for it. So it's really easy if you kind of have like these sort of general assets in mind, like, oh, I need some trees for my game, or I need this code that like simulates an airplane. Like that's probably available to you in some capacity through Unity's add-ons and assets. Unity has a feature called Scene View and Play Mode that we'll look at later, which also makes debugging and building your games really easy. So normally, if you kind of were having to build the game yourself, you'd have to make your changes, build your game, and then like play test those changes, which is like a time-intensive cycle. But Unity has these tools to let you just make changes to your game as you're like testing it out, which makes it way faster to debug. So that's pretty cool. Unity has an extensive community, so there are tons of like resources online, and by extension, that means that there's tons of industry potential for Unity because a lot of people use Unity. So if you want some internships or jobs, that kind of thing, in like a game development field or a VR AR kind of thing, knowing Unity is a great help with that. Unity also natively supports C# out of the box. It is the language of choice, and this is sort of a mostly true thing to say, although it's not perfect. So like, but for any of you who are doing CS at UMD, if you start off with Java, C# more or less is just Microsoft Java. It's gonna look similar enough into what you know, and a lot of concepts do carry over, not one-to-one, obviously, but close enough such that it should feel sort of familiar to you. Next, we have great VR and AR support. So Unity is sort of the backbone for all of that. Like the majority of games made today majority of virtual reality games made today are made for Unity, or with Unity. So it's really nice to have that there. And lastly, you can't see it because my face is in the way. Whoops. It's used everywhere for modding. So a lot of if you fancy any sort of like VR content or VR applications that are built with Unity, a lot of them will allow you to mod them or add your own content via Unity. So it's a good thing to know there. All right. Next up, we have to take a side note. And I have this elephant here. Does anybody know why I have this elephant here? Yes. So about a month ago, Unity announced some pricing changes. And basically, what they tried to do was make it such that instead of kind of charging you some flat rate once you get it big enough, they're going to charge you per install. So for every user who installs your device, they charge you some amount. This was a very dubious move, and well, to say the least, everybody hated that extensively, tremendously, and so much so that as of yesterday or the day before, the CEO was more or less fired. So they have rolled back those changes since then. They're switching to another model, and you can kind of see the details of that here. Basically, they will be getting rid of that like sort of pay per install model, and we'll be doing something more traditional in the industry, but that's something that we have to cover because were you to take Unity full time and like build like a business off of that, this is sort of important. Not so important for our workshop today, but something to note. So that's my side note. Here's a list of like really popular titles that have been made in Unity. So stuff like Beat Saber VR Chat, everybody's favorite Pokemon Go, that's also a Unity title. Of course, Among Us and Fall Guys, stuff like that. These are all Unity titles. They all like build upon the engine in some way. And as you'll see here, if you know these games in question, some of them are 2D and 3D. And luckily, Unity supports building 2D and 3D games. So it's very useful in that regard. But the last thing I want to cover is why don't we do something like Unreal or Godot? I've gotten the suggestion over the past few days, weeks, that why not do Unreal or Godot? Because those are also really interesting engines. We use Unity for a few reasons. One, IMD, which is like the department that gives us this room, the VR AR major at UMD, they do Unity. So for any students in that department, they'll be familiar. Most of our expertise currently is with Unity, so a lot of our mentors know Unity, or people on our project team knows Unity, stuff like that. And like I said earlier, for the benefits of it's very widely utilized in the industry still, these price changes regardless. So we still teach Unity. But that being said, if you do want us to explore Unreal or Godot, we'd absolutely love to like support you in that. We'll just have to learn it together, that kind of thing. And you, Ian, yes, you would like to teach Godot, and I do know that. So we shall begin with Unity basics. So the first thing you need to do to get involved in Unity in any capacity is download the Unity Hub. And this is a free application that you can get from unity.com/download. And basically, this is an app that helps you manage all of your versions of Unity on your system. And it allows you to download the engine, the tools, and it also provides some nice features such as it provides some nice features like tutorials. It'll give you like packages in that regard, all this documentation from within this app. So if you want to like continue your learning and try some of these out via the Learn tab there, this is the app to do that. Put it this way, say meta offices, they probably, yeah. Yeah, it does suck for that the Quest has invested so much into the Unity ecosystem to have the rug pull like that, but no, well. Okay. So once you have the Unity Hub there, one thing to note is you'll see a bunch of Unity versions, and basically the like sort of code name to follow is you'll have what's called major, minor, patch. So the major like portion of the version code indicates like the year typically, and these are for like the huge breaking changes between versions. So they're usually by year. So you have like, 2022, 2023, 2021. And typically, more or less, rule of thumb, you'll probably get some breaking changes if you swap major versions because they're major releases. So it's best not to do that if you don't have to, or just know that you'll be getting into like a thing like that. Minor things are the minor version number just indicates smaller changes that aren't so that do introduce features, but they don't break everything as much. And then lastly, the patch part of the version number is for really small versions, so it's pretty harmless. So for example, for the 2022-3 F1, which is the current version of Unity I have right now, 2022 is the major number, 3 is the minor number, and 3 is also the patch number. There are two types of versions you can get with Unity. There's what's called LTS and text stream updates. So LTS updates are what are known as stable updates, and the idea is like these are more like solid updates that won't break over time. They only a few come out per year, and they are supported for a maximum of 2 years by the Unity team. That way, like if your team wants to build like something long lasting that will just work, it's better to go to an LTS version because that is sort of has the support backbone there. And there's also what are called text stream updates, which basically try to get you the latest Unity features as fast as possible. But for that reason, it is unstable. In some cases, like you might experience bugs that you wouldn't otherwise. So perhaps best not to build your entire game upon an unstable version like that. Next, we have what are called modules. So for every install of Unity, you can actually add on additional functionality through modules. And this tends to come into support in the form of different platforms, language packs, and documentation. So I can actually kind of show you here if I drag this over. I have my version of Unity right here. I can get to like the modules by hitting the gear icon here and clicking add modules. And you'll see that like I have the ability to add support for building for Android. So if I want to target like an Android phone or a Quest, I can add that support here. I have iOS build support already. There's also stuff for Linux, Macs, Windows, et cetera. And I do not speak any of these languages. But if I did, I could also like download translations here. And of course, you can download documentation if you would like that, a local copy on your device. All right, so I know I've been kind of dragging on about like the boring Unity install stuff, but if you're going to take anything away from today, this is the most important part that I'm about to talk about because this is the fundamental knowledge that builds up everything on Unity builds upon these three concepts. And so if you want to get anything out of today, this is the most important to start. And I'll be trying to make some little examples to help you understand. So everything in Unity, and I'll hide myself for a second so you can see, is broken up into like one of basically three things. You have a scene, which is like an environment that you put all of your stuff in. So for example, this room, A.V. Williams, IMD Classroom 3258, this could be considered a scene. And much in like the theatrical sense, it's like where you can set all of your stuff and like arrange things, right? We have a game object, which is basically a sort of building block of your scene. So everything in your scene is a game object. And it's a container for like putting like all of your stuff or like building like your scene in front of. And then lastly, we have components. And you put components inside of game objects or these containers to make them do things, to change the behavior. Now that's sort of a technical description that relies on the other stuff. So in a more simplified sense, here we go. Scene is where your stuff goes. Game objects are little building blocks, boxes that you can put your stuff in, and components are the things you put in that box to make stuff happen. And we'll see examples of this later, and I'll try to give you more examples, and I'll have you come up with a few of your own. But this fundamentally is like the bedrock of Unity, so it's very important that you kind of understand these three concepts here. And by extension, this also gives us like this little kind of fact. If you want anything to happen within your game or application, there has to be a component somewhere attached to some game objects within your scene. If that is not true, nothing will happen. And it might seem trivial now, but like it kind of, you'll see later on as you like learn more Unity that like it is true. Like for anything to happen, there's got to be a component somewhere that's making it happen on some game object. Other thing to note is while game objects are used to build your scene, so for example, a game object might be a car, it might be me, it might be a table. That does not mean that all game objects are 3D models. And this is, we'll see a little bit more of this later, but game objects simply represent like abstract things in your scene, and it's the components that actually introduce like stuff to them. So we'll see later that 3D models, like if you want to actually physically represent like some like model, like a car, a tree, etc., you introduce components that will make that game object visualize those models. But that need not be the case. Like you can have game objects that are just simply invisible, empty game objects. And we'll see that later that this is typically done as a design pattern to introduce things like game logic or pivots for like moving stuff around, and and then stuff like any sort of managers that like sort of manage the state of your game, event systems, stuff like that will also be represented as a game object. And as somebody pointed out in chat, and we'll see in a bit, you can also think of it in sort of a vehicle sense. So the game object like would be like the empty, or as they put it, the empty vehicle frame, and then components would be like the engine, the doors, the windows, et cetera, that actually make the car be a car. The other thing to note is that game objects can contain game objects, so you can have like a hierarchy or a tree. So going on this car model, we can see that we can have like a parent game object that sort of represents a car, and you can kind of think of this like folders. So we have like a quote-unquote car folder, and inside that we have doors and tires, and for doors we have like the driver and passenger door, each that have a handle. We have our engine that has cylinders, 4 of them, and then like tires, a game object representing our tires, and a game object for each of our tires. So you can basically break any sort of thing you want to represent into these game objects, and represent stuff like that. And that's useful because for one, any like sort of game objects that are children of like some parent game object, so with the parent being like sort of like the one like on top, and then children being all of its descendants, those children will move along with the parent. So in the case of this car example, if I move that car game object at the top, everything underneath it is going to move along with it. So you can imagine that this is useful if you have like some sort of like large complex object that you don't want to move every single part individually yourself. You can just move the topmost and then control everything like that. It's also useful for organization as well. Unity does not have folders like some other engines offer. So if you want to sort of organize things in your scene, you'll do so in the form of game objects that are empty and they don't have any components, but you can still like group stuff together that way to achieve the same functionality that you want. One thing to note is that even though like game objects will move along with their parents, components are still applied to singular game objects. And what I mean is that like if you add a component to the car, that only applies to that specific car game object. It does not automatically apply to any of its descendants. You would have to propagate that and add it to all the add that component to all the children. But in that way, it's like you don't accidentally like multiply behavior over all the children or anything like that. And lastly, if any of you are 3D modelers, if you import some sort of rig from Blender or similar 3D software, the hierarchy that's created in Unity will match the hierarchy that's created in Blender. So as a sort of exercise, I have me. that I can represent myself as like a series of scene game object components, right? So the scene in this case would be the IMD classroom that we're in, right? The game object is me, representing me. And then in terms of components, I have a brain, maybe eyes, ears, et cetera, et cetera, et cetera. So you can imagine that the components, or like my quote unquote organs, are the components introducing behavior into me. So eyes allow me to see, brains allow me to make poor financial decisions, ears allow me to hear, et cetera, et cetera, et cetera. And then if we go back to the car example, a scene might be like like a dealership. That might be your environment. The game object is the car, with nothing, like just the conceptual thing of a car, and then the components would be the engine, the doors, steering wheel, et cetera, et cetera, et cetera, that change the behavior of the car. So yeah. That being said, you can find all this sort of concepts and further information on the documentation. So this is a great resource for trying to find the nitty gritty details of anything like that. Anything from like concepts to code, all of that is available at docs.unity3d.com. And what's nice is that they also keep track of the documentation across all versions. So let's say that something was true for an earlier Unity version like 2021, but is no longer true for 2023, but your team still uses 2021, you can go back to the 2021 version of the documentation and still access everything there. So it's very nice in that regard. But at long last, we have covered the theory, or like the very basic theory, and now to help you kind of put into perspective, we can start looking into the actual Unity editor itself. So if I have it actually here. So this is Unity, voila, voila, voila. This is assuming you just download a Unity project, or you download Unity Hub and you launch an editor from scratch. This is what you'll see. And I should mention, in order to see this, you have to create a project, and we do that via the Unity Hub. So if I come to my Unity Hub, I can come up here and I can click on New Project. In this drop down here, you can change the editor version if you happen to have multiple versions installed. But for now, we'll just do this one because it's just selected. And you get a bunch of templates here. Typically, these like allow you to like get your project started with like different features already pre-installed. And this is sometimes helpful, sometimes not, I found in my experience. So for today, if you just want bare bones project, nothing, no fancy bells and whistles, the best thing to use for that is just 3D. You can come here to the, you can click on this template here, and then on the side, you can give it a name. So I can call it, I don't know, Intro to Unity Workshop, name it like that. You can choose a folder to put it in. I'll keep it in my GitHub folder. Create project, and then Unity will go ahead and create that project for you. So it takes a second. You can't see it. Oh, now you can. Excuse me. That takes a few seconds. You can kind of have that going in the background while you wait. But while Unity does its thing, I will go on to sort of describe everything. So going back from before, we can kind of split the editor into these different regions. We have a toolbar at the top, a hierarchy on the left, scene and game view in the middle, inspector on the right, and a project explorer and console on the bottom. Well, what does that all mean? First, you have the toolbar. This is the thing at the top of the display here, so what I have shaded in purple. And this is basically used to sort of control the state of your project. So the most important thing on the toolbar is those three buttons at the left there. There's a play, pause, and step button. So play button is how you, like after you're done making your changes in your scene and you want to actually test your game for real, or like with all like everything working and stuff, you can hit the play button and it will start going. There's a pause button. So if you're, while the game is running and you want to like pause to like see what's going on, if you want to stop things, you can hit the pause button, and then all like your game will basically freeze. And then there's a step button, which basically allows you to pause the game one frame at a time. So if you know your like console, like if you know your sort of gaming / display terminology, games produce frames. So like if you ever heard like 60 frames per second, That's because your video game or application is producing a new picture like 60 times per second. So in the case of this toolbar, stepping through those frames is like pausing after each and every frame to inspect something. We also have some nice convenience features like an undo history, so you can see all the latest actions you did and like revert them or anything like that. And there's also a layers feature, which you can use to toggle visibility of layers, but that's a feature we'll talk about later. And lastly, there's a layout feature here, and that basically allows you to change like the panes around or your windows like layout. So if I want something like this, where I mostly look at the scene view, I can do that. You can do 2x3, which is like putting more windows out. We'll just stick to the default for now, but once you get kind of more familiar with the Unity workflow and you realize that you want to like have a certain you like a certain configuration windows, you can go up here and load it from here, and you can even save it. So if you have a favorite, you can go back to it later. All right, next up we have our hierarchy. So if you remember before, a scene in Unity contains a series of game objects in some order, and basically in this hierarchy window is where you go to both add game objects and manage like the parenting of them. So if we go to this Unity example here, I can click on this plus button for this, and there's like a bunch of things I can create. So if I just want like an empty game object, no strings attached, literally just nothingness, I can create something. I can click here. This is create empty, and that will give me a new game object. So I can call it like my epic game object, something like that. And let's say I have another one. I can say my child game object. And if I want to ever create like this parent-child relationship where I want to put like my quote-unquote child game object underneath the parent that is my epic game object, I can just drag it here. And much like you would drag like a file in a folder, you just drag it over the parent that you want to make, and then let go, and it's now parented like that. So it's kind of hard to see now. We'll get a better look later, but you can if I move this parent here like this, the child will follow. But we'll see an example of that later. So let me go back. So yeah, so once you do have like your game objects in the scene, some other things you can do. Oops, that again. If you hover over like the left-hand side here, it's kind of hard to see in the projection up there because it sort of fades off on the side. But there's a little eye icon and a finger icon. The eye icon will hide the game object from the scene view. So if I come here and I go to 3D object and I make a cube like this, and I hit this eye icon here, it disappears. I can also like usually I can click on a game object or anything within the scene like this to highlight it or to select in the hierarchy. But sometimes it might be annoying, like you have something that's really large that gets in the way a lot of the time and you don't want to ever click on it. You can click on this finger icon here, and I can no longer click on it in the scene view. Just like nothing happens. All right, so that's basically the hierarchy. So as a recap, we can create new game objects by coming to this plus menu up here. So I can create an empty game object like this. There's some presets here, so I can create 3D objects. So I just made a cube. I can make a sphere like that. I can make a light. So there's different types of lights. So I have spotlights, point lights, directional lights, all different types of lights. So if I want to make a point light, or rather something that emits light in every direction, I can create it like this. And if I drag it up here, it's kind of hard to see, but it will sort of illuminate the surface of the cube. And if I ever want to delete a game object from the hierarchy, I can just right click and I can click delete. Or at the same time, I can hit the delete key on my keyboard, and that will delete the game object from the hierarchy. All right. Next up, we have our scene view. So the scene view is basically the portion in the middle that allows you to sort of set your scene. You can move around your scene view by holding down right click and using WASD, much like any sort of video game. And then there's also a series of tools available to you that allow you to move things, rotate things, scale game objects, and there's a series of keyboard shortcuts for them as well. So I have this list here. If you get Q, you get the pan tool. So if I like, whoops, again, if I hit Q, I get the pan tool, so I can just sort of drag and move around my scene like this. Also gonna bring my cube back. If I hit W, which is like the move tool, I get this what's called like these gimbals here that allow me to like they'll create like a x-axis, y-axis, and z-axis little arrow that I can use to drag it around. So I can like drag it around like this, like that, up and down. It's kind of hard to see, but there's like these little shaded regions, but that basically allows you to manipulate the game object over several axes. So I can move it along the YZ plane like this. So notice how its X direction doesn't change. It's XY, so the Z direction doesn't change, and etc. So that's nice if you like, that's particularly useful if you have like something on the floor and you don't want to change its height. Then you can just grab this little thing here and then just move it horizontally, but not actually change the height of it. Next, we have like this rotate tool, so I can access it by hitting E or by clicking this thing here. The rotate tool, as the name implies, allows you to rotate game objects. So when you, it'll introduce these handles, and you can just like sort of drag it. You can drag any one of these back and forth like this to start rotating your game object. So there's one for every like axis, so like X, Y, and Z. But there's also this like gray circle one on the outside, and that allows you to manipulate the rotation from your current perspective. So if you imagine that like this gray wheel is sort of like a steering wheel. So from the way I'm looking at it right now, I can sort of turn that steering wheel like this. So it's like basically rotating like as if I'm like sort of, you know, have a steering wheel attached to it. And I'm like moving it left and right. But if I change my perspective such that like this, like I change like the way that this circle is like oriented relative to the cube, now it starts spinning it like this. So all these transforms tools. Another thing of note is that as we see in the slide here, you can hold down Control to start like snapping. So what that means is like, you know, if I have this cube here and I want to rotate it, but I don't necessarily want to like have to, like I might just want to rotate it 45 degrees and I don't want to have to like line up precisely 45 degrees. I can hold down Control and it starts snapping in like, I believe 15-degree increments. So that's really nice for rotation. And that also works for translation as well, or for moving. So if I start moving it left to right like this, and I hold down Control, you'll notice that it starts sort of snapping in these increments. And that way I can really precisely position something in the scene right on the decimal point. Next up, we have a scale tool. You can get to this by hitting, I believe, R. Yep. And this will basically allow you, as the name implies, to scale your game object. So I can scale it in the Z direction, Y direction, X direction. And if I use the little white box in the center, I can scale it all uniformly. And then lastly, there's also some other tools, but these are more useful for 2D games / UI, which we won't cover today. But if you want like a tool to kind of do them all, the last one is the transform tool. You can get to it by pressing Y. That will basically allow you to do everything I just said in one tool. So you can scale, you can move, you can rotate, do the whole shebang, all from one tool. So that is like a quick overview of all the tools. The last thing you need to know about the scene view is, next slide here, is basically the idea of local versus global mode. So you can see up here that we had this little drop down that says local versus global. And basically, if you don't have like a math background, or like if you haven't taken linear algebra, I guess, you don't need linear algebra, but this basically tells Unity how you want to move and rotate the objects. So right now we have local selected, and that basically means that we are going to be moving and rotating our game objects relative to their like coordinate spaces. So as you see here, this green arrow, green, red, and blue arrow all sort of are aligned with the cube. And so if I move the cube left and right, it's relative to the cubes left and right. So we can see like in our world that like, it's not actually, it's sort of moving at an angle. And that's because we're moving relative to the cube itself. But let's say I want to move left and right absolutely in the world. We can come here and we can change it to global, and you'll notice that now our arrows are like perfectly aligned with the world grid right here. So we can now move it like in a global sense, like exactly along the x, y, and z axis, or x, y, and z axis, xz that exists globally. We also have we can also change between what's known as the pivot and center. So this is sort of hard to demonstrate right now because we only have a cube. But basically, what this means is if you had a really big game object that had like a lot of intricate parts, it allows you to basically move that game object either from like the pivot, which is basically wherever the parent game object is, or the center, which means it's going to like try to calculate, given all of the game object's children, like where is the center of the thing. So for example, in the context of a car, like the parent car game object might be like on the front of the vehicle. But when we want to move and rotate the car, we probably want to do that from the center so that we can rotate it nice and evenly. So if we're in center mode, it changes the location of these tools here to go towards the center of your game object, so it's easier to manipulate. What else? So I believe that's sort of the major features there. We have like these other tools here that allow you to configure all these settings. So we have a grid visibility button here that lets you turn the world grid on and off. We have a snapping button that allows you to snap the game object into specific intervals. We can change our increments. So if we wanted to snap in like 30-degree increments instead of 15, when we go to hold down Control, we can do that there. We have what's called a shading mode that allows you to change the way that Unity renders the scene. So right now it's in shaded mode, which is the default. But if I wanted to see what's called the wireframe of all of my game objects, or rather the exact like makeup of like the individual 3D models without any textures or like imagery, this allows you to do that. Although this is more of an advanced concept, so I'll kind of gloss over it for now. You can turn lighting on and off. So right now lighting is off, but I can like turn it on and off to change to like activate and deactivate lights. We can mute all sound. We can toggle other settings. And lastly, the other important things are we can also change the view of the camera that's used for the scene view. So if we want to increase the field of view for while we're working, we can like drag it all the way up. We can also narrow it really far down so that it's less easier to see things, and change other settings there. But I know that was a lot, so I want to pause for a bit and ask if there are any questions so far. A lot of this I'm sort of saying, not expecting for you to obviously remember, because like I don't remember half the time. It's like something that I come across when I need it. But I'm more so saying it for like the recording's sake, and also like I'll provide you the slides as documentation in our Discord, and then like I'll announce it elsewhere. That way you can kind of go back and like see them as your reference. But yeah. And once again, to reiterate, if you want to move around within your scene, you can hold down right click, use WASD like a video game, and that will allow you to like move around. And lastly, you can also these little like symbols here, you can use it to like align yourself on a particular axis. So if I want to look at it from the top, I can click the little green thing that's pointing up. I can look at it from the right, left, and then I can also click this thing in the middle to change between two modes, which are called isographic and perspective. Basically, in perspective mode, you sort of render from like the perspective of the camera, but in orthographic mode, it's kind of hard to explain, but basically you start viewing things from like infinitely far away, which means that like it doesn't matter their distance to the camera, they all appear the same size, and this can be useful for like aligning things along in your scene. It's kind of hard to demonstrate, but we'll look at it more in depth later. All right, next up we have the game view, and this one's really simple. Basically, When you go ahead and click this play mode to run your game, you'll be brought to this, which is the game view. And this is basically the view that your player would have if they launched your game. So if you are listening, if you have any sort of UI that pops up with little icons, stuff like that, that like a score counter, you would see it in this game view here. If you like had mouse and keyboard controls, or like a gamepad, like an Xbox controller, whatever, you could connect those here and start moving them. Right now, if I do any of that, nothing happens because, well, there is no, we haven't introduced any behavior via components, so nothing will happen. But yeah. And you might be wondering, like, okay, we have the game view, but like, where does that view actually come from? And typically for scenes, that will come from this game object here called main camera. It has a camera component that like designates it as like a camera that like we can actually look through. And if you notice, if I go to the game view and I change some parameters about the camera so I can increase the field of view, that'll like allow us to manipulate the view that our user sees or our player sees. All right, that's the game view. Next up, we have the inspector. So I sort of like cheated and kind of started using this already, but crucially, the inspector allows you to start modifying, modifying the properties of all of your game objects and their components. So when you click on a game object, it will reveal that game object in the inspector. And from there, you can start, you can add components, you can edit their properties to change the behavior. You can also do things like change the name of a game object. You can change its position, rotation, scale, stuff like that. And yeah. So like if we go back to Unity here, if I click on like this cube, you can see here that it gets highlighted in orange, which indicates that like it's a currently selected thing in the inspector. And for here, I can like see it has like an x coordinate of -0.385, 1.233, -2, and I can change this value. So if I change it to 2, it moves up, 3, etc. I can change the rotation. So if I want to get it back to like facing just normally, I can set all of its rotation values to 0, and now it looks like aligned with everything again. I can change the scale back to like, so I can change the scale around, so I can make it like really tiny by like doing like 0.0001, or I can set it back to normal like this by setting them up to 1. But yeah, you can also turn game objects on and off. So you see right up here, we have this checkbox. If I uncheck it, the game object deactivates. So it no longer exists, basically. It still exists within your hierarchy and your parents, so still sort of move along with your parents, but it won't do anything. So as you can see here, when I disabled it, like the cube essentially disappears. And if it had any sort of components that like change behavior, they get deactivated as well. So yeah. Next up, we have, let's see. Oops. We have, at the bottom, we have our Project Explorer. So basically, whenever you add stuff to your Unity project, files, pictures, audio, any of that, you'll manipulate it all from here. So this sort of is like where you can get all your folders and stuff. This also tends to match the folders that are on your computer. So if I go ahead here and like see the scenes folder, I can right click that scenes folder. I can click on show and explore, and you'll see here that like it brings up like the folder as it exists on my computer, and you'll see a scenes folder here, a scenes folder there. You'll see these .meta files, but you don't really need to worry about them. It'll all kind of match. Whenever you want to create a new type of file within, like if you want to introduce a file into your project, you can right click the empty space and you can go up here into create. And so you can create a variety of different things. We don't really know any of this stuff yet, except for a few things. So if we just want to make a folder like anything else, I can make a folder. I can call it test. Now I have a test folder. I can double click the folder to enter the folder. In terms of other things we can create, if you want to create a new scene, so you can have multiple scenes. So right now we have this one scene here. If I want to create a new one, I can go here, say create scene. And that will allow me to make a new scene. I can call it my test scene. I'll save this. And if I want to enter the scene, I can double click it, and then it changes the scene to that new scene. But I can actually change back to my previous scene because I had this other folder here called scenes. I can double click it, and then I'm back. But make sure to save. And you can save by doing save scene. By clicking there. What else? Generally, in your assets folder, if you see like a larger Unity project, it'll be split up into multiple different folders, depending on the type of things that you store. So for 3D models, we typically keep all that 3D data in a meshes folder. For scenes, we typically give them in a scene folder. For the code that we create later on, we keep them in a scripts folder, et cetera, et cetera, et cetera. But this way it helps you sort of organize the project so that whenever you introduce new people to your project, they can be like, oh, I know that I have to work on some scripts. I can go to the scripts folder, find it out. Or if I know that I want to change some models around, I can look in the meshes folder. This stuff is all basically by convention, so there's nothing forcing you to use this methodology. But as of note, there are two folders, editor and resources, that if you name them editor and resources, they actually do have a meaning. Basically, if anything in the editor folder is only available to the editor, or the Unity editor, so if you want anything to actually be used within your game, don't put it in the editor folder because it won't exist from that perspective. And we also have a resources folder that basically, it's more of an advanced feature, but it will allow you to load anything you put into that folder at runtime, which basically means that when your game is actually playing on somebody's device and you want to like load up a picture, if it's in the resources folder, you can like actually load it while the game is running, which is a useful thing, but not something that we'll cover in the scope of today. And last but not least, and in our whole Windows spree, we have the console. And this is basically a little message box to help us like figure out the state of our game and application. So when you go to create components, you'll see in a bit that you can actually write messages to this console in the form of info, warnings, and errors. So if I pull it up here. So if you see in this little screenshot, I have like a sample message here in this console that says hello world. This is what's called an info message. So this generally is just meant to inform you as a developer that, hey, this is going on, no biggie. So you can use it to help you troubleshoot things. So if you're trying to figure out why something isn't working, you can put these, you can add these info messages into the console that allow you to figure out what's going on. We also have warning messages, which basically tell you as a developer, hey, something's not right. It's not that bad, but you should be aware of it. That'll come in the form of warning messages, and they'll be yellow. And lastly, you have error messages, which is basically, oh no, something's gone terribly wrong, like crap. Those will also appear there. And as a tip, sometimes you can double click on one of these console messages, and it will show you which game object in the hierarchy sent them. But that isn't always the case. But yeah. This. All right. So that's the console. And last but not least, we have what's called the package manager. So if you ever want to introduce new functionality into your project, let's say you want to add VR support, or you want to add 2D support. Well, by default, the bare bones Unity that you're given doesn't really have that. And so if you want to actually add that, we can come up here into Window, Package Manager, and then that will open up this window here that will basically allow you to add what are called packages. And this basically allows you to install or remove additional functionality to the engine. You can get these packages online. So if you typically as you follow tutorials, they'll tell you, oh, you need this package. You can go download it from the package manager. And you can also download community packages here. So if you ever see something in the community that's made that introduces functionality into Unity, this is where you can go to download that as well. Next up, we have the asset store. So part of the largest thing really that makes Unity is that it has a collection of assets that you can get. Some are free, some are paid, but this basically allows you to get introduce different pre-made stuff into your project. So I can actually Google it here, Unity Asset Store. So basically, if you ever want to be like, oh, I need this for my project, like I need trees, then you can come to the Unity Asset Store. You can search for trees, and then there's like a bunch of different like trees you can import into, like you can look at. So I see this thing here that says free trees. What I can do is once I search this up, I can click add to my assets like this. I have to sign in, which is unfortunate. So I will pull this up from here, the asset store, blah, blah, blah. I'll sign in with Google, so that's faster. There you go. So it gives me some sort of license agreement, which for us as students, if you're just playing around, you don't really need to follow, but be aware that for any sort of commercial purposes, it is important that you read these licenses because that'll tell you like how you're allowed to use these assets. So now we can just hit accept. And now I have added this to my assets. I think I can hit this button here that says open in Unity. It'll ask me if I can do that. And I also need to sign in here. Should just work. Yep. So I've been working in Unity for a while, so I have a bunch of assets. But if I look up here, we can see that I have this listing here called free trees. I can click on download here. It'll go ahead and download those trees. And once it does, I can finally hit this import button. It'll basically tell me like, hey, here's all the stuff that comes with the trees. Do you want to import all this? And I can say, yes, I do. And I can hit this button here that says import one last time. Unity does a little thing. And now it has been imported. But if we actually want to use these things that we just imported, we have to go to the project view. And you'll see now that there's this new folder under the name of the author. If I click here, I see there's a free trees folder. There's all these folders that like make up the trees. I can go in here and you see here that there are trees. So I can like just drag these in like this and voila, I've gotten trees. So this is like, once again, like the asset store is really nice for any of this stuff, like the grunt work that you don't really want to do. If somebody's already done in the asset store, you can just download it, put it in your scene, and there you go. Going back, oops. Not bad. And this is the final concept I have for y'all today. We also have prefabs. And so basically, prefabs are a feature of Unity that allow you to, if you have like a game object that you're using multiple times, like for example with the tree, you know, it'd be really annoying to just like continuously make game object after game object after game object after game object and configure every single one of them to introduce your tree. Well, prefabs are functionality built into Unity that basically allow you to create templates and then reuse those templates anywhere you want. So going back to the tree example, I know I'm going to use a tree a bunch. I can make my tree game object, and then I can turn it into a prefab and then start using that as many times as I want and not have to reconfigure anything. And these are incredibly powerful because you can also like package like functionality into prefabs. So any components you add can be included in the prefabs, and that way it's literally just like a drag and drop operation. So what we saw before with the trees here, those are actually prefabs. And you'll notice that they're in a prefabs folder. But that basically allows me to just like, I don't have to go ahead and like, you know, create, add all the stuff. I can just keep adding, dragging, and stuff like that. Yes? So when you say create your own trees, do you mean to like actually model your own trees or just like? So for that, we'll probably use a program like Blender. That way you can like create the 3D model of your tree and then you can import that into Unity. That's outside the scope of today's workshop, but we do typically have a Blender workshop later in the semester. So if you want to learn that, we'll teach you that. But good question. We have so you'll notice that all the prefabs here in our scenes are blue. And this is so you'll see here that the text is blue, and like the cube that is here that is blue, and this indicates that it's a prefab. As part of a prefab, you also have the option to, per prefab that you introduce into your scene, you can override properties of it if you want to like make changes to that specific thing. So for example, this tree here, let's say for whatever reason we wanted to make it smaller, we can like adjust the scale, so now it's much more compressed. But notice that by doing so, I didn't change all the trees in the scene, I just changed this particular tree. If you want to actually make it apply to everything in the scene, there's every like instance of the prefab in your scene, there's a few ways to do that. If I right click here, you'll see that on the scale property, it has this blue line indicating that it was overwritten. If I right click it, I can click this button here. This is apply prefab to prefab. And what that'll do is that they'll basically modify all instances. They'll like change the original prefab so that everything that uses it will follow along. I can also come up here. So if you want to keep track of all the changes you made on a particular game object or prefab that you've imported, they'll be all under this overrides tab here. You can click this button, apply all, which will basically apply all of your changes to every single thing, or you can reject them all and like undo everything, and you can get back to the original state. And last but not least, with the prefabs, if you want to ever like look at the original, you can come down here in the folder and you can double click on them, and you can see just that like single copy of it and make all of your changes there. And making any changes here will propagate to all the copies you have in your scene. And so the last thing to cover is just basically how you make your own prefabs. So if I get rid of this tree for a second, let's say I want to make like this sort of water molecule in like the form of like spheres or whatever. So I'll create some spheres like this. Oh, and what I just did, by the way, is I double click. So if you ever want to focus on something in the scene, like and like zoom in on it, you can double click it, and then it will bring your perspective to the game object in question. So I have a sphere. Let's say I want to like turn it into a water molecule and make it look like a water molecule. I can copy and paste it a few times. So I'm going to copy by hitting Control C, Control V. I'll make a few copies. And then if I click this out, or click on our game objects, I have made some copies of spheres. I want to kind of make it look like a water molecule by making them smaller and putting them on top. So I'm going to change the scale. So instead of 1, it would be like 0.25, 0.25, 0.25. Now it's about the quarter of the size. I'll do the same thing over here. Because I want these spheres to sort of move with the bigger sphere, I'm going to like make them children of this bigger sphere here. So I'm going to drag them like this, drag them like that. And now if I move this sphere here, it moves all of them together, and I can bring them, like making them look much more like a water molecule like this. Not to scale, no worries. But like that. So now if I want to make it a prefab so that I can just make multiple copies, it's really simple. All you have to do is take whatever game object you want to turn into a prefab from the root, or from like the very top of where you want to make the prefab from. Just click and just drag it into your project window, let go, and boom, you'll have created a prefab just like that. You'll notice it turns blue to indicate that it's a prefab, like there's multiple copies of it. And now, since we've done this, I can just take this thing here, drag multiple copies as much as I want, like that. Huh? They're smaller only because like they're just farther away. Yeah, they all are the same size. All right. The last thing I have to do before we actually commence our demo is going over the components. So in Unity, there are a lot of components, so many that we would never cover them in a workshop. We could spend an entire semester talking about them, but I've sort of handpicked a few that are most useful. So remember that components are things that we introduce a game object, we add onto game objects to change the behavior. So the first most critical fundamental component is the transform. This is a component that is on every single game object, and it is an exception because it is the one component that must be there and it cannot be removed. So you cannot like take a transform component off a game object there will always be a transform. So this component basically, as we've seen in past, it just allows you to change the position, rotation. You can't really see it because it's a sphere. I can kind of double click on it to try to focus. Position, rotation, and the scale. So that is sort of the most basic. There's some no. So that's transform. Next one is what's called the mesh filter. So I said earlier that just because something is a game object does not mean it's actually a 3D model. And here's what I mean by that. For something to be a 3D model, you need two things. You'll need a mesh filter component and a mesh renderer component. So as we have in this slide, a mesh filter, basically you provided the shape or rather like what's called the mesh of your 3D model. So, and that defines like the physical shape of that 3D object. So in the case of a cube, it defines like that a cube has 6 faces, that kind of thing. And you need a mesh filter in order to like introduce a 3D model in. So that's the mesh filter. The next thing is what's called a mesh renderer. Oh, yes. Why are they separate? That's an excellent question. I am not entirely sure. I guess it's just like a separation of functionality because sort of, I guess the mesh filter describes like shape-wise of like whatever you're trying to visualize. And this component here, the mesh renderer, modifies visual appearance. I suppose they could be the same component, but they're separated out. Oh, I do actually know why now. Because you can have the same mesh, but it can be rendered in multiple different ways. So by the 90% of the time, 90% of the time, it'll be done through this mesh renderer here. But there's something called also a skinned mesh renderer that also is used typically for avatars or like your player models, so that you can actually like manipulate like limbs and animate them and stuff like that. That uses a different renderer, so that might be part of the reason why it's separate like that. Because they both reference the same mesh, but the skinned mesh renderer would allow you to manipulate or do the animations and stuff like that. But that's more of an advanced feature. We're not really going to cover it today. A mesh renderer also has like a materials field here, and so this basically allows you to change the visual material of it. So if I click the circle here right next to this, I can look at the materials we have in our scene. We don't really have that many materials yet because this is a very bare bones project. We'll look at how to create one later. But you can see here I can swap it for like this thing here. Now this is like our sphere looks different. It's got some different properties, and that was accomplished by swapping the material. So to sort of reiterate, a mesh filter defines the shape of your 3D model, and a mesh renderer defines the visual appearance, like the actual like how its surface looks in that regard. And you need these two components both in order to visualize anything in your scene, or to have like a visual representation of any 3D model. You'll notice that if I take any one of these components out, so if I delete the mesh filter by clicking these 3 dots and clicking on remove component, now there's no mesh anymore, so there's no notion of shape, thus you have nothing to render. And vice versa, if I take the renderer out, you have a shape, but nothing to tell it how to actually draw or render that shape. So you need them both. Next, we have we can look at materials. So materials are basically how we can tell Unity how to make something look. A great site to get a bunch of materials from, or like the things you need to make a material, is called Ambient CG. So if I go to ambientcg.com, and I hope that this Wi-Fi works. There you go. This is basically a free thing that you can use to like basically get any like these are more realistic materials, mind you, but you can get like a whole bunch of stuff here. So let's say I particularly fancy this marble. I can come here. I can click on 1K JPEG.zip, which basically or this like these listings here like designate how high detailed the textures are, or the this material will be. So I'm just going to download the lowest size now, just for time. I can come in here. I will drag it into my project, or I will put it in my project. I'll extract it. This. So you'll see that when you download a okay. When I download a material or from like this site Ambient CG, you'll see here that it comes in a variety of different pictures like this, which is not what we want. We want like a material that we can actually apply to game objects to have them render differently. And so for that, we need to create a material. In Unity, we do that by right-clicking empty space in your project window, going to create, and then material. And this will allow you to define a new material. So I can call this marble, like this. And this is the new material, but obviously it still looks white. We haven't actually told it how to be marble yet, so we need to do that. And you notice here that if we click on material in the inspector, it shows all these different properties, but here are the most important. So where is my present? Okay. These parameters tend to vary based on the material, but these are the most common. So you have something called albedo, which basically defines, if you have some sort of surface, this will define like the colors on top of that. So if I have like a picture or something with like that, like shows, or like in the case of our material we just downloaded, this will be the albedo because it has like all the color information. We also have what's called the metallic map, which is basically indicates how reflective a surface is at that particular point. And that can be used to sort of make really shiny materials or make them really dull, that kind of thing. We also have a normal map, and this is a special texture that looks, we'll see here, it looks really blue. You might wonder, like, well, what's going on there? Well, a normal map is like a special way of encoding a vector into like a texture. So a vector being like a direction. So this tells Unity, if I were to like map the surface out, like where is the surface pointing out of at that particular point? Because we have a flat surface here, all of them are pointing up per se, like there's not any sort of like weird bumps in it. They're all kind of flat. And for that reason, we have a mostly like flat thing because they're all sort of facing the same direction. You would see this like for any sort of 3D models that have more advanced normals or more advanced like feature or like shape. This would look a bit different, but for now it's blue. And lastly, we have a height map. And basically, a height map is a way to sort of fake like little imperfections or like height differences along a material. The way it does this is a little tricky or complicated, but generally you don't really have to worry about it. You can just drag it in and apply it. So now that we know all those different types, we can, to actually like make this marble material that we've created, utilize these pictures that we've downloaded. We just drag them in one by one. So we have this, which is our albedo. So I just drag it from here into this little square box here. And then now we have, it now looks like marble. We have a height map here. So I can take this and I can drag it into here. We have a normal map. I can take this, drag it into the normal map. Oftentimes when you do this, it'll complain that, that it's not marked as a normal map. You can just click this button, fix now, it fixes it. And last but not least, we have a metallic map. I can drag it in here, and now I can change how smooth and shiny it is using the slider. And now with all those different parameters into our material, we can just drag our material onto the object like this, and it will turn it marble. And so you can, so if you want to apply material, you can either do what I just did, which is drag it in like this, or you can also come here to whatever game object you want to change the material of. You can go to its mesh renderer. You can also drag the material in this material slot here. That will also change the material type. And you can also do, you can also click this button here to search up all materials within your project. So if I search up marble, you can see I have it here. And if I double click, it also becomes marble. So many different ways to apply material, but it's whatever really floats your boat. The next important colliders, concept of colliders. So in your game, you typically like want to have like some sort of physics where, like, you know, if you have like a car and it runs into a box, you want it to collide with the box and the box to go like shooting off into the distance. But to do that, you actually need to define like how far, like with every object, like where, like what is like the shape of it and how can it bump into things. And so we do that through colliders, which basically allow us to define the region of space around an object that will bump into things. And we have different types of colliders for that. So we have a box collider, which basically says for some game object, we can define a cube size thing around that game object for it to interact with. So if I take an empty game object here, and if I search up box collider, I can add it like this. And you can see here that it now defines this region around a game object in green, such that if you were to come into this space, you would collide with this game object. We also have a sphere collider, which basically defines a spherical region around that game object to collide with. Case in point, a capsule collider, which basically defines like a pill shape. So right now it looks like a sphere, but if I modify this height property, I can make it look like more like a pill. And then this is really useful for any sort of player colliders, because if you want to represent a player in your scene, that's typically done through a like capsule. That way it sort of is more accurate and not just like a giant box. But yeah. Next up, we also have a what's called, let's see, my list. We also have terrain and wheel colliders, but those are more specialized and outside of the scope of today's workshops. The last thing we can talk about is what's called a mesh collider. So if you have like a mesh, like let's say if I introduce like a car in, and you want the collider to really closely match the shape of the car itself, you can use a mesh collider. So you can just like, so I could do this for the sphere, like it would have the same effect. Like I can add a mesh collider, and basically like this will like take the actual geometry that represents the sphere and then turn that into what is collided with. A question that like arises from this is like, well, if I have colliders and I have a mesh, like why don't I always use a mesh collider? Like why do we even have box or sphere or capsule colliders when we can just use the mesh? And the answer is because like if you think about it, the more sophisticated your mesh, the more detail on it, the more work it has to be done for the physics system to determine a collision happened at exactly this point. So it like meshes, like yes, they allow you to define exactly the shape of your object, but that also comes at a performance cost, because you'll just have so much detail that it takes so much longer to determine whether or not you've collided with something, that typically, for all intents and purposes, you can use something like a box, capsule, sphere collider to just get the rough approximation of your object, and that's way, way, way faster to do. And to kind of make it a little bit better, you'll notice that a mesh collider has this checkbox here called convex, and basically that will, instead of like matching the details of your mesh exactly, it will just try to take or wrap around it per se. So I guess it's really best if I sort of Google this convex. Yeah. So as we can see from like this like model here, we have on the left like the exact mesh. So we can make a collider out of this, but it'd be way too detailed and way too slow. And so what a convex does instead is that it basically tries to find the minimum amount of space such that everything in the minimum shape possible, such that everything in your mesh is contained within. And it basically you can imagine it's like kind of wrapping your mesh with like wrapping paper. It goes around it, and in this way it covers generally all the space within the mesh, but it's like much less detailed, so you can use it for something. So here's another example of that, like with this dragon. We have like the very detailed dragon within, but it's convex. In convex mode, we would only really like take this shape on the exterior of it that fits the entire dragon inside. All right. Next up, we have get back to it. A rigid body. So when you introduce colliders, you typically also introduce a rigid body. For this reason, I'll show here. A rigid body basically tells the physics system of Unity, hey, this is something that can actually be acted upon. You can put forces on this. It can be collided with. Gravity can affect it. You do that through a rigid body, and that basically will allow you to modify its parameters for the physics system. So you see here that if I take this thing we have here, and I hit, I'll undo, I'll reset all the overrides so it looks back to normal. If I hit play, nothing happens, because even though we have colliders here that say, like, you know, if this were collided with, this is the region of space for that collision to happen, without a rigid body component, the physics system will completely ignore it. So if we want this to actually sort of fall and respond to gravity, what we can do is we can take the parent of this, like a sphere here, or of the sphere. In fact, we can also go into the prefab itself and modify it so that everything else, all the other spheres will be activated or turn into rigid bodies. So I can actually click on this arrow here to go to that prefab. And I can come here, I can add a component. So by clicking this add component button, I can search up rigid body. And now this is now going to be acted upon by the physics system. So it's actually going to start like responding to things crashing into it or gravity. So now if I hit play, you'll notice that with the rigid body, all of them begin falling. Some fun things you can do are you can turn off gravity with this checkbox here. So if you want something to sort of be floating in space, you just turn off gravity. Now if I hit play again, you'll notice that all of them are still floating. But if I, let's see, if I bump one into the other one, you'll notice that they start like moving around. That's because the physics system now is saying these are now physical objects. If they're collided with, they have to start moving. Without the rigid body, if I brought these near each other like this, nothing would happen. But it's specifically with the rigid body that they begin to move. So that's how you start to kind of add physics into your scene. And this, another useful component is if you have sound effects, you can use what's called an audio source component, which basically will allow you to add sound effects and stuff to your game objects and have them play sound and stuff like that. That's done through this component, and if you want to specify the specific sound to be used, you can just basically drag in any sound you want. So that's the nice thing about Unity. It basically supports all that out of the box. I do not happen to have a sound file on hand, but actually I could probably make one. I typically basically go to I just Google free sound effects and go for whatever site. So okay. If I just search up like a glass, I don't know, like a ding or something like that, or glass shatter, and you can't hear it because the speakers don't work. But I'll turn up my laptop so you can hear it. But basically, if I God, Um,
Following.
if I follow. If I oh my I guess I have to sign in to download it. This site is annoying in the sense that yes, you have to make an account, but it's really nice for making Unity applications because, well, you all that work is done for you. So I will just download the sound. I'll download it to my downloads folder. And what's also cool about the project viewer is that if you just drag a file in, it will just be added to your project. So I have this folder here for the audio file. I drag it in like this, and boom, it's now in our project. So this is now an audio clip that represents like the audio file. So if I come out, if I exit play mode, I'll add my audio source like this. And I can drag my clip in like that. And so now it's equipped to play the sound. Here I have controls for like adjusting the volume, which I will preemptively turn down. You can adjust the pitch of it, make it sound higher or lesser pitch, all that kind of stuff. You can make it loop if we'll do that for fun. The last checkbox to be aware of is what's called play on awake. Basically, with this checked, as soon as the game object is created in your game, it will just play the sound. But if you want to ever have it so that like you control through like some other component exactly when that sound will be played, you can uncheck play on awake and it won't play as soon as it's created. But because we want to hear it, we'll add that sound, and if I hit play, yeah, that's what loop does. If I turn off loop, it will stop doing it. Can I get it to... I'll also show you what like the fun things you can do with like the priority things. So if I change the pitch, it sounds much higher pitch. That apparently changes. You can even reverse it, make it really low pitch, all that fun stuff. All right. That concludes like a bunch of basic components. Once again, I know this is like a lot of components, one after the other. These are sort of the most important ones. You can always watch this recording later, look at the slides to look at the details for any particular one. But those are sort of the basics. So now we will finally move on to the last sort of topic before we quickly throw something together, and that's scripting. So Unity has a bunch of default components that we can use to create a bunch of things, but obviously we want to sort of make our own components, and that way we can like really define what makes our game our game. And so, for example, you can imagine that if we're making like a Flappy Bird game, we need like or a clone. We need a component that will basically tell the game Unity like, okay, whenever the user clicks on the screen, you need to move this game object up and like add a force to it so that it moves up and like falls back down. That also all has to be done through custom components, or in the Unity sense, it's done through scripting. So the way we create custom components is through C#. This is the programming language, like I alluded to earlier, that allows us to program all these interactions. There's many different IDEs you can use to write C#. My favorite one is Rider. As UMD students, you have access to this program for free. Normally it's paid, but I really like it because it is basically engineered to work with Unity out of the box, and it has a lot of nice features. So it looks also really nice. You can also use Visual Studio, which is also free from Microsoft. You can even use VS Code. But the most important thing, whatever your choice is what you have to make sure you do is whenever you want to change your editor of choice, or you want to make sure that it's working, you have to come up here to Edit, Preferences. I'll drag this over. External tools, and you'll see here this external script editor. This will basically tell Unity which IDE you're using, and this is probably required to make it like work way better. So right now I have Rider selected, but if I wanted to switch over to Visual Studio, I would click that, or Visual Studio Code. And part of the reason this is so important is, one, it makes it so that whenever you double click a script or a C# file in your project window, it will open that file using that editor of choice. And number two, I found in my experience that typically if you want your editor to be useful, that is to have it like autocomplete things for you, you'll want to have it selected here because I think part of that is enabled to this functionality. But yeah. So with that being said, so we can go ahead and we can make a custom script by right-clicking in our folder. We can click on C# script, and I can call it like hello world. And this will basically create a new component for us that we can use. This workshop isn't really intended to be like a heavy programming one, so I'll try to keep the details light. But basically, for those of you who are aware or who are CS students, I will open this file up. Loading. So here we have our script. Every single component in Unity must inherit from mono behavior. This is sort of the base class that all components utilize. And if you don't do this, you won't see it as an option as a component in the menus. You won't be able to add the game objects, etc., etc. The also important thing to keep in mind is that the name of your component here, or the class, must match the file name. If they don't, it will also cause it to not be registered. So you need them both. So with this new component, we can actually already add it to our game objects. We can do so just by like one of two ways. Now with it in the system, we can click on add component. We can search up hello world, the thing we just made, and my head is in the way. We can search up hello world. It is now here. We can add it like this. Perfect. The other thing you can do is you can drag it over from like your project window onto a game object and let go, and it will also add it like that. But of course, you know, we now have a component, but it does nothing. So how do we actually make it do stuff? This is done through what are called events. So basically, events are what your component will rely upon to actually know when to do things. So Unity has a bunch of events built in. These are functions or methods that you create within your script that you can put like instructions underneath to make it do stuff when an event happens. So these are called by Unity. You shouldn't really call them yourself. Unity will kind of do that for you behind the scenes. So we have a bunch here. So for example, when you create a new component, two will be given for you by default. And you can see here that, also, yeah, what's nice about Rider is that it'll tell you which ones are event functions. So you can see it's telling me that this is an event function. So is this. Start, as this comment says, it's called whenever, after the first frame. So basically, once you create your game object and it gets set up, once it gets rendered on the next frame, so like if you're once again, like there's multiple frames, or your program or your game makes a bunch of frames. On the next one, start will be called, and that's where you can set stuff up. We also have update. So basically, this is code. This is a function or method that will be called for every frame in your for every single frame in your game. This will be called. So if you have any effects that need to be or logic that needs to be done continuously, like constantly, like change the color of this, or like change the speeds or anything like that. You do that update because that'll be called repeatedly. And we have a whole bunch of other stuff, but these are sort of the most important, start and update, and we can take a look at them here. So the other thing we can do is we can also create parameters for our component that we can change from the inspector. And we do this via introducing public variables. So for example, if I wanted my component to take in, be able to have an option for an integer, I can do that by just saying like public int, int being for integer, my integer, and I can save it. And so if I go back to Unity, it will recompile my thing. And now you can see in my hello world script, I have this parameter here for an integer, and I can change it to whatever I want. And basically, by doing this, this will make it so that whenever my game object comes, or with this component comes into existence, it will have 500 for this parameter, my integer, already set up and for reference. And the nice thing about it is like this can be changed per game object. So where did I put it? So you can change this for multiple game objects, and you can configure it all in the editor. You don't even have to touch any code, and that can be extremely useful for like time, so that you don't have to keep going back to the code every time you want to change a little minute detail. You can do so like this. We also have a bunch of different data types, so we can have an integer. If we want to have like a decimal value, we can do so via float. So you can say of type float, my floats. This will create a float called my float. We can have text via what's called a string. So we can say public string my text. And this will allow us to introduce text. We can also have like a yes, no Boolean type value via a bool. So you can be public bool, my bool. And this will give us all of our different types of data. So if I reload this, we have a decimal value here. So I can say like 0.5. I now like we can have text, so I can say like hello there, and like I can have a yes no value. You'll notice that all of these are public. So for like the people with the CS background, public means that basically anything can access it. And in terms of Unity eyes, it will basically take it so that like if you ever have anything declared as public, it will go ahead and automatically add it to the inspector. However, if I change this to private, like this, and I let it recompile, you'll notice that my checkbox for my bool disappears. Now, sometimes you actually do usually want to make these private, and that's because if you have other components that want to like interface with your component or like do stuff with your component, you really don't want them editing the parameters like sort of willy-nilly, because they might not do it in the right order, yada, yada, yada. So you can make something private and still have it show up in the Unity editor by specifying what's called the serialized field attribute. So it's just like these little square brackets and then typing serialized field inside. And if you save it like this, it reintroduces this back into the inspector in Unity, so I can change it from here. But the important thing is like now with this functionality instead, if any other component tries to use my component hello world, they won't be able to change this directly because I still have it as private. So serialized field lets Unity change it from the editor, but in terms of your code, it makes it so that only you have control over this. The other thing, so those are sort of like some basic data types. What's also cool is that we can have references to other game objects and components. So I can do that by just specifying like game object as a type like this. So I can have my other game object. And if I, let's say, wanted to have like a rigid body to manipulate, I can do so by typing rigid body like this. So my other rigid body. And when I do that here, Unity will give me in the editor like these reference fields. So right now they say none because we haven't dragged anything in there. But what I can do is I can actually have it refer to any game object. So if I want it to refer to the camera, I drag in the camera like this. It's now the script has a reference to this camera here as its game object. So in this current configuration, whenever I try to examine the properties of this from the code, it will actually do so. It will be directed towards the camera. So I'll start modifying the camera stuff. You can also specify like a specific component. So with the game object, they'll let you basically drag anything with there. But with a rigid body, something has to have a rigid body. So a camera doesn't have a rigid body. So if I try to drag it in, you'll see this little X sign because it's not allowed. But if I take our spheres, which do have rigid bodies, it does allow it, and then the spheres can go in. So this is really useful if you want to be able to configure stuff from the editor, and stuff like that. And then lastly, we have a variety of different methods you can call. These are useful when you're trying to actually like manipulate components and stuff within your code. So we have add and get component, which basically allows you to create components to either create or get a component attached to a game object of a specific type. So if I wanted to encode, like make a rigid body, I can assign it to a variable called var, or so I can say var my new rigid body equals add component, or rather game object dot add component rigid body, and that will basically not only like programmatically create a rigid body component and add it to my game object, but it also gives me, it returns it, so now I can manipulate it here. So as you saw earlier, we had like a checkbox for whether or not gravity is enabled or not, and you can see here that that's also here too. So I can say use gravity is false, and now my new game object will have this rigid body and it will not be affected by gravity. There's a whole bunch. Another important one to know is debug.log. So if you want to ever make a message show up in the console to help you like figure out what's going on, you can use debug.log, and then you can put in some text. So I can say like debug.log start was called, and then here I can put debug.log update was called and save it. Now if I go back here with this component, you'll see in the console, oh god, minus the glass, you see a whole bunch of messages here saying update was called, update was called, update was called, update was called. That's because it's an update, it just gets repeatedly, called every single time like a new frame is made. I can come up here and click on collapse, which basically tells Unity if any messages come and they have the exact same message contents, you can like sort of nest them together or group them together. So you can see here that like I had this counter here that represents that like have over 12,000 like update was called messages pending. But you'll notice that start was only called once when it was created, just like that. We also have instantiate and destroy, which are basically the mechanisms that you use to create prefabs, have a game object, create a new, take a prefab and like add it. So if I have like this thing here that says, my other game object, and I want to create a copy of that game object, or if I want to create it from a prefab, what I can do is call instantiate my other game object. Or my other, and that will programmatically both create the thing in the scene, and then it will return it so you can start manipulating it. So this is particularly useful for prefabs because you can either drag other components in the scene like our camera, or you can drag a prefab in the slot like this, and it will also have this sort of blue cube here indicating it's a prefab. But this allows you to create copies of that through code. So we could have like a thing where we can make like a loop that creates 10 of these like sphere things and like lines them all up. You can do so using instantiate. If you ever want to destroy something, you can call the destroy functions. So as soon as we make a new game object, I can have it be destroyed, so you actually don't even see it ever. So just like this, and then it will be destroyed. What else? The last big thing is basically that for every component, when you have it like this, when you extend from mono behavior like this, you'll have some variables given to you by default, them being like game object, so you can like get a reference to the game object itself, and you can do things like add a component, get a particular component of it, that kind of thing. And you also, because as I alluded to earlier, every game object has a transfer component. You can also just type in transform, and then this will give you properties of the transform. So we can get stuff like position, rotation, stuff like that. Position comes in two forms. So we have the position, like this position, which represents its position in world space. So this basically will change as the position moves around the scene. But sometimes, let's say we want to make like if we have a wheel, or rather like if we have like a wheel like on a car, we want to position that wheel relative to the car, not necessarily like the entire like world. And for that, we can use what's called local position, and that will allow you to set or position something relative to a transfer's parent or game object's parent. And yeah, so that was a lot, I know, but that basically is a complete crash course on all of what is Unity. So the best way to kind of like learn this stuff for real is to actually go ahead and build something. So for that, we have about 20 minutes. Does anybody have something they'd like me to build that's very primitive but would be interesting to show? I have a backup idea if nobody has any ideas, but I'm open to like just like stuff like Flappy Bird clone, whatever. Anyone? No? In that case, I will build a Flappy Bird clone. To do that, we can first kind of think conceptually, like I'll kind of clear all this stuff out. We will make our Flappy Bird cube because I'm not that good at modeling, right? So you can imagine with our Flappy Bird thing, we have like the bird itself, we have like some obstacles it has to run into, and we want to like keep track of a score of how many obstacles it's cleared and do that. So first, I will go ahead and sort of create the iconic sort of quote-unquote flapping like mechanism. So for that, I have my cube, and I'll just create a new component here called bird, and I will add this to here. Oops. Oh, this is so I can drag this like this, and now I have a bird component. But basically what I want to replicate here is the actual like flapping of the bird. So to do that, I know that the bird will be affected by gravity. So I will already add a rigid body component that will allow gravity to have an effect. And so if I start playing like this right now, it will fall, but we want to actually have it like be able to move up and down. So to do that, I'm going to need to have my custom script basically say something like whenever the spacebar is pressed, we're going to give it some force that pushes it up to make it quote-unquote flap. And so to do that, I want this to happen sort of continuously. So I want to put this in update because I want the game to continuously check, is the space key pressed? If so, we're going to add a force to the rigid body that will push it up. So first, what I can do is I can add an if statement. And in Unity, to test whether or not a key is being pressed down, we can use what's the input class. So I can say if input dot space or get key or get key down, and I can do key code dot space. This will basically be called the first time I actually press the key or the space bar. So it goes from not being pressed to being pressed. It will execute this code. So for now, I'll just have like a debug statement that says space bar pressed. I will also turn off gravity for now, just because I want to focus on the cube and not have it like fall everywhere. So now you'll notice that nothing's happening, but if I click on my game view and with this new component, if I hit space, you'll see in the console that we have these messages indicating that the spacebar is pressed. Fantastic, that works. Now we want to actually like sort of add a force to it, like to make that flap happen. So what I need is I need to be able to take this rigid body component and tell it to add a force that will move it upwards. And to do that, what I can do here is use a method that's available to every component called get component. So I'll do like rigid body is equal to get component of rigid body. So what this line here is saying is we're going to ask our game object, hey, look at all of your components and see if you have one that is a rigid body. So that's what these angle brackets here are for. They allow us to specify the type of component that we want. In this case, we want a rigid body. If we do find a rigid body, assign it to this variable. So now I have a rigid body here. Because I have it here, it will work. So now I can take this rigid body, and it has a method called add force relative. And then this will basically allow you to specify a force that is applied relative to the rigid body in question. So we want to have it, no matter how the bird is facing, we want it to sort of be like get pushed up. So we'll do like this. And so we can specify a force in the form of a vector 3. So to make a vector 3, I can type in new vector 3, and then I have like 3 parameters, an x, a y, and a z, like this. Oh, and like that. And so in Unity, the up direction is like the y component of a vector. So if I want to give it like a force to move it up, I can just like do, like I'll give it like 5 quote unquote newtons of force. And now if I save the changes, you'll see here that it's ever so slightly moving up, like the more I move it. Obviously, that wasn't a lot of force. So what I can do instead is I can change this value here. But, you know, it's going to be really annoying to like constantly go back to this code and change this value. So what I can do is I can actually make this a variable so that we can edit it from the inspector and just do it that way, which is much easier. So what I can do is that I can say public float flap, or I guess jump force, like this. I can give it a default value of like 50. And then instead of having this 5 here, I can refer to jump force.
Can you make jump force static also?
Or what?
Static.
If you make it static, it will no longer appear in the editor, but you can still manipulate, like you can, but you'll have to manipulate that for your code and not the editor.
But will it not render faster if we use static? Because then it's allotting memory only once.
I wouldn't necessarily say faster. You really wouldn't want to make it static per se, because like if you had multiple birds, for instance, like you might want to configure the force per bird, in which case you want to like have it separated. So you can see now that I have 50. I can hit space, and now it's moving a bit more, but I want to increase that force even further, so I can hit it, add another 0, and now I hit space, it really flies off the screen. I can bring gravity back into the mix so that it starts falling again. There it goes, but you know I can bring it back up if I keep. There you go. Yeah, so it requires a bit more tuning, but basically this allows me. Right here, I can. Yeah, it's falling again. I can try to, or you can also have these open at the same time, which is useful. Yeah, so that allows me to change the direction more or less. You can make this a bit nicer. You can also change the way that the force is implied. This is getting a bit into the more physicsy part of it. But basically, there's if we want to make it like sort of immediately change, immediately apply the force. I think I might be able to say impulse.
I think that's the correct one.
Yeah.
The one time that I followed a Flappy Bird one that said that.
Yeah, so impulse, and now if I should move, I'm gonna move the camera real quick so that like it's in line with our cube. So line it like this, like this. There we go. a bit too much force still, so now I will, or I'll turn gravity back on. Figure where my cube went. So this is a bit better. If I can, like, now with gravity back on, I can sort of... It's not perfect, but you kind of get the point that, like, it's moving at least a little bit the way we want. One thing I could do to fix this is that I can basically say... What I can do is basically say... if, you know, like the Flappy Bird reaches the ground, it like just like hits the ground. And I can do this either through code, but the simpler way, the more simple way is I can simply just make a plane for it to rest upon, like this. The plane has a mesh collider, so like the, it's hard to see. Move this around. That's the cube. Up. So now instead of just falling to the ground all the time or falling through the floor, this will lie on the plane, so that way it's a bit easier to see. I also give my Flappy Bird this marble texture we made earlier, the material. That way we can actually see it or distinguish it better. Now like this, I'll turn gravity back on. High, I'll bring it back down, adjust these values a bit more. So there we go. So now it looks a bit more like what we expect, and then when it hits the ground, it will actually hit the plane. Or what? Ah, good. So we can actually do that. So for that, what I'm going to do is I'm going to move this cube a bit further up so it doesn't immediately hit the plane. But to tell when it actually crashes into something, this is a event function that Unity gives us. It requires that the two things have rigid bodies. So we have our cube with the rigid body, but we also need a rigid body in our plane. So we'll add it like this. We don't want our plane to like float away, so we'll turn off gravity. But furthermore, we don't want our plane actually moving at all. So what we can do is we can check this checkbox called is kinematic. And what that means is whenever it basically tells the physics system, don't ever like act upon this like object. That is, don't ever like move it, don't rotate it, don't turn it, just have it collide into stuff, but never, it should never like be acted upon or start moving. So to tell from the bird's perspective that we've crashed into something, we can use what's called on collision enter. So this is an event function. As a parameter, you'll get what's called a collision object, and then this will give you parameters about what happened or like what was collided into and stuff like that. But I know from this that like that the only thing in my other thing it could collide with is the ground, so I can just say like ground was collided, or rather you crashed game over, like this. There we go. Now if I hit play, try to keep it in the air. Oop. So I have it floating, 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 but if it crashes, it'll be you crashed game over.
You just made the function. How does it know that the cube and the plane are colliding? If there are multiple objects then?
So the way it knows that they're collided is that's what Unity sort of is taking care of you behind the scenes. So Unity's physics system recognizes that
I think what he's asking is like, how can you tell if those specific two objects collided? Because currently you're just saying,
okay.
Hey, did I collide with something?
In that case, so if you ever want to check specifically what you collided with, that's given. So you start using that other parameter. So what I can do here is we can say you have crashed into, and then I can do, this is one nice thing about C#. We can add a $sign here to put in parameters. So to add information to our strings. So I can say you have crashed into other dot rigid body dot, do we have a name? Yeah. So what this will do is other dot rigid body will contain will have a reference to whatever you collided into. So right now what I'm just doing is I'm just taking the name of that. So if I name this plane the ground and recompile it, oh, I guess the name didn't apply, but I can actually change it on the fly like this. And now if I have it collide again, it'll say you've crashed into the ground, game over. So with that, you can do whatever fancy logic you need to check what exactly you've collided into. But yeah. The other thing I'll just try to quickly get working is our like quote unquote pipes. So for that, I will, we'll see how much I can do in like a few minutes. But basically, I can create, I know I'll have multiple pipes, so my goal right now is to make like a prefab that I can create and like start moving. So I'll make like a pipe. It will be, there's the pipe. It'll be here. It'll kind of be a bit long. This. One nice thing you can do with materials, you can also like just change the color of a material. So we don't have any textures, but what we can do is like just with the default thing you get, we can change the color. So I can make this green, and I can drag it like this, and so that will give us a pipe. So I can make this into a prefab like this. So now we can make multiple pipes. The next thing I want them to do is basically just move to the left. So I have these moving in the X direction. So the X, I want them to basically move right to left. So that basically is decreasing in the X axis. So what I can do is I can make a pipe script that just continuously takes our transform and just moves it to the left. So I'll just do like a transform.local position minus equals new vector 3. I don't know, like a pipe speed. I can make this variable, do 1f. 0, 0. So this will start moving it basically all along like that. Typically, when you're moving stuff like this, you actually want to make this what's called a fixed update. And this is different from update in that this is independent. Update is called based on the frame rate. So if you have like a really fast gaming monitor with like 240 frames per second, it's going to be called 240 times per second. But if you're doing like on a mobile device with only like 30 frames per second, then that update is only going to be called 30 times per second. So you don't want like your physics code being called like behaving differently based on the device. You want it to be fixed, and so that's what fixed update is for. So now I can have like a pipe like this. I can add a pipe component to it. I'll set it to something a bit lower because I know that it's going to be a bit fast. So now you can see that the pipes slowly move. Right now, I have not specified a rigid body on them because that's why, but now that if I do the pipe and I make it kinematic so that like the pipe doesn't get moved, it moves other stuff. Oh, I have to save this. Flux collider. This has a rigid body. Okay. There you go. So now I can push like the bird around and stuff. What I can do now is now that I have one pipe, I want to make multiple pipes. So what I can do is like I can make a new script called pipe creator. And so this will be an example of like a game object, like having a game object to manage something, but not actually having any sort of physical 3D representation to go along with it. So I'll just create something called pipe manager, or pipe creator. It will have a variable that's called pipe, which is the pipe prefab. So basically, this is where like we'll specify the type of pipe that we want to create, and basically I want it so that like for every every 5 seconds or so, create a new pipe. And the way we can do that, it's a bit more of an advanced technique. But first we'll specify pipe interval equals 5. This will say we want to create a pipe every 5 seconds. So F in C#, if you want it to something to be like a decimal, and specifically float, it's for F. So you can't just do 5.5. You need to specifically say 5.5F, and that indicates that it's a floating value. You can do 5.5D, I think, for double or something like that, or not, but this. I know we're low on time, or a bit over, so I'll just try to do this real quick. So to do this feature, it's a bit more complex, but bear with me. What we're going to use is a feature of Unity called coroutines. And so whenever you want to have something happen every like such amount of time, we use a coroutine to sort of define that behavior. And we first do that by creating a function that has a return type of IEnumerator, and we're going to call it like create pipes coroutine. And so basically what we're going to do is every time we get called, we're going to create a pipe prefab just where we are. We're going to make it spawn in. So we're going to make our new pipe like this. New pipe to transform.local. We can set our local position to be the center of the world. A little bit more, so we'll have it spawn a bit to the right. So let's see, where's this pipe right now? This is at about 3 and 1.5. So I can say, the cool thing too is you can make positions or vectors also variables. So pipe spawn position, like this. And I can say pipe spawn position. I change this from local position to position because I want to manipulate the pipe in world space. Like I want it to spawn exactly at a certain spot, and I can do it like this. And so then what makes this a coroutine is that I can do is I can say yield return new wait for seconds. Pipe interval. And so what this piece of code does, it says, okay, I'm going to create a pipe, and then I'm going to wait for 5 seconds, and then finish. As is, this will basically create a pipe, wait 5 seconds, and then complete. But if we want to make it a loop, we have to add like something like while true up here. And what this does is like it continuously just says, gonna make a pipe, wait 5 seconds, and then go back, make another pipe, wait 5 seconds. You can't do this in an update loop because if you think about it, update, if you do a while true in your update, basically Unity will become stuck in your particular script or your component because you're basically like, Unity is just continuously trying to do your while true and it will never escape. So your game will essentially freeze. So coroutines are the way that we can sort of fix that by having Unity say, when we want to wait 5 seconds, we're telling Unity, okay, Unity, continue doing whatever, but in 5 seconds, come back to me so I can do this again. And in order to actually call our coroutine, we need to call this method here called start coroutine, create pipes coroutine. And so basically this will tell Unity, okay, I want you to start our coroutine that will continuously make this stuff. Here it is right here with this create pipes coroutine function. And I'll put it in start such that it only happens once. And if I were to put into update, that coroutine would be called every single frame, which would be bad. But yeah, so now I can do pipe creator. I can drag in my pipe prefab like this. I want the pipe to spawn here, so I can look at where this pipe is right now. I can copy this position, paste it like this, and then I'll change it to something a bit faster like 3. So now, if I hit play, after 3 seconds, there you go. Yeah, a bit more work to be done in that regard, but you can see how sort of piecing this all together, you can start doing really primitive behavior. Obviously, throughout the semester, throughout the year, we will show more in-depth projects taking advantage of this stuff. We also have our help channel and our office hours, or like our lab hours as well. So if you ever have any more specific questions, you can just put it there. I, myself, and our other people in the projects team can help you out. But that is basically a very crash coursey introduction to Unity. I highly recommend that you look up YouTube tutorials as well, that documentation online. Unity Hub also has like a few tutorials that you can get from the Learn channel that will help you like build something more specifically. So they have stuff like making like modeling, like little mini projects that will actually guide you step by step how to build something from start to finish, much more than we were able to today. But yeah, that is basically Unity in a nutshell. So thank you for coming. As always, like I said, if you have questions, you can always ask me. But I hope you enjoy the rest of your night.